For today's class, we are going to look into partial fraction, how we can resolve algebraic fraction into partial fraction. Before now, if we have two algebraic fraction, we've learned how to add or subtract. So before we move to this topic, let's do a revision on that. So let's make it quick. For the first one, we have 3 divided by 2x plus 1 minus 2 into x plus 2. The LCM is 2x plus 1, x plus 2. From here, if this divide this, we have this multiplying 3. That will be 3 into x plus 2. Then we have minus here. If this x plus 2 cancel this, we have this. So this will now multiply 2. That will be 2 multiplying 2x plus 1. So we leave this denominator this way. So by the time we simplify this, the final answer is going to be, we'll get this. So let's write this answer in front here, then we'll move to the next one. So we are done with the first one. Let's move with the second one. We have 1 over x plus 1. So here the LCM obviously will be their product. X plus 1, x plus 2, x plus 3. So if x plus 1 cancel x plus 1, we have left with this 2, multiplying 1. So that will be x plus 2, multiplying x plus 3. Plus, if this x plus 2 cancels x plus 2, we have this 2 multiplying this 2. So this one will go, we have this 2, that will be x plus 1, then x plus 3. Minus, if this x plus 3 cancels x plus 3, we have this 2, multiplying the 2 there. So this will go, we have this 2, x plus 1, x plus 2. Now let's expand and see what this will lead us to. We expand this, and see what we get. The expansion of this gives this. The expansion of this gives this. Then for the last one, if we expand this, we get this. You can try it by yourself. So first, let's all cancel. Here I have 2x squared here, minus 2x squared, cancels. So we have x squared as the only square. 5x plus 8x minus 6x should give us 7x. Then 6 plus 6 minus 4 should give us 8. Then everything over. So let's put this answer in front. We are done with the second, so we can move to the third. Alright, to the next. Now for this particular one, the LCM is going to be x plus 3 all squared. For example, if I have x and x squared, the LCM is x squared. If I have x plus 1 and x plus 1 all squared, the LCM is x plus 1 all squared. So in this case, the LCM is what? X plus 3 all squared. So when x plus 3 cancel the square, we are having 2 multiplying x plus 3. Then we have minus 3 here. When this cancels, that will be 1. By expanding, we are having 2x plus 6 minus 3 divided by x plus 3 all cubed. So this becomes 2x plus 3 over x plus 3 all squared. That's the final answer. Let's place it here, then move on. The next one is similar to this, as you can see. 2x minus 1, 2x minus 1, 2x minus 1. So the highest power will be the LCM. So this will be the LCM. So we are going to write everything over 2x minus 1 all cubed. So when 2x minus 1 cancels this, from cube it turns to square because this has the power of 1. So 3 minus 1 is 2. Then to that coefficient, we are going to have 2x minus 1 all squared. Plus, we have 3 there. When 2x minus 1 squared cancels 2x minus 1 cube, we are having what? 2x minus 1. Then you have plus 1. 2x minus 1 all cube, divide this to give me 1, because they are the same. So by the time you expand everything up here, the final answer will be 8x squared minus 2x minus 1 all cube. You can expand that yourself for confirmation. Now look at this, the next one. The LCM is definitely their product. That will be x plus 3 multiplying x squared plus 1. So when this takes this out, we'll be having this. So that will be 2 into x squared plus 1. Plus this takes this out, we'll be having x plus 3 multiplying 3x minus 1. Let's expand and simplify. We have this. Then from here, 2x squared plus 3x squared give us 5x squared plus 8x minus 1 divided by the denominator, and let's put the answer at the front. Alright, for the next one, we have 2 plus 3x minus 1, 3x plus 1. Recall how to add a fraction with your own number. So this multiply this. So we are having 2 into 3x plus 1 plus what we have here, 3x minus 1, and the LCM will be 3x plus 1. So by the time we simplify this one, the final answer is going to be 9x plus 1 over 3x plus 1. Let's put the answer here. Moving on to the next. Alright, for this, same thing. This multiplies this, so we'll be having 3x multiplies 2x minus 1 plus 3 over 2x minus 1. So this gives 6x squared minus 3x plus 3 over 2x minus 1, which is the answer to this. Okay, for the last one, we're having 3x over 2 plus that. So the LCM is obviously 2 into 2x plus 3. When 2 takes away, we have 2x plus 3 multiplying that. So we're having 3x into 2x plus 3. And this plus 2x plus 3 take this one, we're having 2. 2 multiplying 2x minus 1. After we simplify what you have at the numerator, the final answer will be 6x squared plus 3x minus 2 into 2x plus 3. That's the answer for this. Let us add one more question. Now let's consider this question. So for this, we have 2 plus x plus 1 by 3 plus 4 divided by x squared minus 4x plus 1. I carry this as over 1, so the LCM is 3 multiplying x squared minus 4x plus 1. So 1 goes here, nothing, so everything multiplied 2. 2 times 3, that will be 6 into x squared minus 4x plus 1. Plus 3 cancel 3, we have this multiplying that. So we have the x plus 1 multiplying, x squared minus 4x plus 1. Then this cancel this, we have 3. 3 times 4, that will be 12. Plus 12. Then let's expand and see what we get at the end of the day. So this is what we get. So put the answer in front. Just like expansion and factorization, it is easy, or it is easier to expand than factorizing. So that factorization gave us a tough time a bit. So for example, factorization of quadratic expression and also other forms of factorization like the difference of two squares that we did before this class. Now, I believe by now, if we have any algebraic fractions, we know how to add or subtract to get, a single fraction. Now this is the problem. How can we return this back to its original? And this is what the topic is about. This is what partial fraction is all about. Now, let's not take it case by case. All these problems are selected, and these are all the cases you can have. These are all the positive cases, all the possible cases. Okay, back to the first page. Consider the following single fractions. How do you resolve this in partial fraction? Same goes for this and this, this, and this. The first thing is, the standard way of writing any algebraic fraction is to put them in a proper fraction. So if you have constant up, what is below can be linear. If you have linear up, what is below should be quadratic. If you have quadratic up, what should be below should be cubic. Example, 2 over x plus 1, constant linear. Or x plus 1 over s squared minus 5, linear quadratic. Or s squared plus 5x over s cubed minus 3, quadratic cubic. That is the standard. So if you understand this, that is what you are going to use in each of these cases. Now in this, we have two denominators, 2x plus 1 and x plus 2. Anytime you have a fraction in this form, you are going to write what? A over 2x plus 1 plus b over x plus 2. So where a and b are going to be constant, either 1, 2, or 2, 4, and like. So these are you split. So first is to learn how to split first. For the second one, it means we have three denominators. We have x plus 1, we have x plus 2, and we have x plus 3. So our what will be above them should be constant. So that will be A, B, C. Why for this one? This is repeated denominator. So it means I'll have x plus 3. And we're also going to have x plus 3 all squared. And what we have a constant A, B. For this one, repeated denominator. So we are going to be having 2x minus 1, 2x minus 1 all squared, 2x minus 1 all cubed. Then we are going to have what? Since we are going to have A, B, C, and that will be plus plus. For this one, we have linear, we have two denominator, x plus 3, we have x plus 3, and we have x squared plus 1. For this one, what will be on top should be linear, should be a constant, but whatever is quadratic. So if whatever A is quadratic, what we have above should be a linear equation, which is going to be bx plus c. So in this case, our aim is to get the value of a, b, c. Note, if the denominator is linear, what we up should be a constant. If what we have below is quadratic, what we have above should be what? Linear, as we have it here. But anytime we have quadratic as the denominator, try to factorize first. If you can factorize this into two brackets, then it follows this approach. But if you cannot factorize, you leave it this way, then this becomes this way. But if it is factorizable and you continue this method, after you solve, you are still going to have what you can still resolve to a partial fraction. Now you now see this last four, they are all improper fraction. From 1 to 5, they are all proper. I don't know if they are proper. Below, we have what? Quadratic. Goes to two linear gives quadratic. So, linear quadratic, proper. Quadratic cubic, because we have x, s, s, s cube. This one is what? Linear cubic. Sorry, linear quadratic. Is still, this one is quadratic cubic, because we got this to give us cube. This one is quadratic cubic, because s squared and s give us s cube. But this one, although they are both linear, but what you have up is small. It's obvious. Then it is what? Improper. For this one too, improper, because you have quadratic linear, here you have quadratic linear, here you have cubic quadratic. So anytime we have improper fraction, we are meant to do what? Polynomial division. So we're going to divide, which we've done, how to divide two polynomial. So I think it is better we start with this example to see. Now let's start with example 6. Then after that we'll come to this. So one thing is obvious, depending on the nature of the denominator, will determine how we are going to split. And if you compare how we splitted this into how we came across all these fractions, all these fractions were the answer we got initially when we started the class, or the expansion. So when you compare all this to the answer, they look the same. So now let's start with number 6. Number 6 is when we have improper fraction. So how do we divide? So we want to divide, let's say 7 over 2. So put 7 inside, 2 outside. 2 in 7, 3. 3 times 2, 6. Subtract 1. So from here it means 7 over 2 equals to this quotient 3 whole number plus remainder 1 over divisor 2. So what will be inside should be the numerator. So we have 9x plus 1. Outside here we have 3x plus 1. So 3x plus 1 divide 9x plus 1. X cancel x. 3 in 9. That's 3. So we have 3 here. Then we multiply 3 times 3x, 9x. 3 times 1, that's 3. Then we subtract. 9x minus 9x cancel. 1 minus 3 minus 2. So it means from here, 9x plus 1 over 3x plus 1 equals to quotient 3. Plus remainder minus 2 over divisor 3x plus 1. Minus plus minus. So it means 9x plus 1 over 3x plus 1 equals to 3 minus 2 over 3x plus 1. And that's all. We cannot further divide this into partial fraction because that's one denominator and constant here. So that's the final answer. We are done. So there are some, after division, you've already resolved to partial fraction. If you are to combine this, you'll get this, which you can make a reference to the example we did before this. Now, this answer might not look like the question we solved to get this. It is well from the question itself. The fraction used, that is 3x minus 1. If I can remember, 3x minus 1 over 3x plus 1, that and plus 2. this itself is not written in a proper way, so we can still resolve it in a partial fraction. We are done with number 6. So note this down, so move on. Now number 7. Write number 6 first. Now number 7. So we want to divide 6x squared minus 3x plus 3 by 2x minus 1. 2x cancels 6x squared. 2 in 6, 3. X cancel x squared, x. Then multiply. 3x times 2x, 6x squared. 3x times minus 1 minus 3x. So let's subtract. This cancels, I have 3. So what's the final answer? It means the whole of this becomes this quotient 3x plus remainder 3 over dividend 2x minus 1. And that's the answer, because this cannot be further splitted. Now let's move to the next, number 8. We want to divide 6x squared plus 13x minus 2 by this. Let's just expand. That's 4x plus 3. Or we can take out the half. We can write this one as 1 over 2. Then we have 6x squared plus 13x minus 2 divided by 2x plus 3. Yes, we can also write it this way. I think it's better in this form. So now, after bringing out this half, let's now divide what you have there. So in this case, we are having 2x. Initially it's meant to be 4x plus 6, but we are still using 2x plus 3. This divides this. So from here, 6x squared over 2x will give us 3x. 3x times 2x is x squared. 3x times 3, that's 9x. So by the time we subtract, this goes away. 13 minus 9 gives us 4x. Then minus 2. But we're not going to solve. Why? Because these 2x can still divide 4x. We keep dividing until what we have here has lower degree. 2x divided 4x, that will be 2. 2 times 2, that's 4x. 2 times 3, that's 6. We subtract. Minus 2 minus 6, that's minus 8. This time around, this number has lower degree than this, so we are done. So it means this becomes, the half still remains outside. Then we are going to have the quotient, which is what, 3x plus 2, plus the remainder minus 8 over divisor. I will call dividend, it's meant to be divisor. So that's the answer. Or we can decide to simplify further. From here, if you take out or take in the half, this becomes half times 3x becomes 3x over 2. Half times 2 becomes 1. Minus times minus, that's what? Plus times minus is minus. Then half of 8 is 4 over 2x plus 3. So if we combine this, we get this. Although when we look at the question, the penultimate question we solve, we combine to get this answer. We have 3x over 2, yes. But what we have, I think we add 2x minus 1 over 2x plus 3. And because they have the same degree, that is why. But this is the proper way of writing it. So this is the final answer. If we combine this, we get this at the end of the day. Let's move to number 9. Let's try its answer in front first and rearrange. Before we move on, one thing is obvious. In mathematics, it is not allowed, as in partial fraction, it is not allowed for also have division of for two numbers of equal degree. Maybe x minus 1 over x minus 3, or x squared minus 1 over, let's say, plus 1 over x squared plus 2x plus 5. If we have anything like this, we can always resolve them to partial fraction. That is one. Secondly, if it is improper in this case, we must always divide. So if you have them having same degree, we consider them to be improper. Now to the next. Similarly, this 3 we can bring it out. This is 1 over 3 into s cubed plus 3s squared minus 7x plus 19 divided by s squared minus 4x plus 1. So here we want to divide s cubed plus 3s squared minus 27x plus 19 by s squared minus 4x plus 1. So s squared divided s cubed should give us x. Now let's multiply. X times s squared, s cubed. X times minus 4x minus 4s squared. X times 1x. Now let's subtract. This first always cancel. 3s squared minus 4s squared give us 7s squared. Minus 27x minus x, that's minus 28x. Then this 19 comes down. They have same degree, so keep dividing. S squared divided 7s squared, that's 7. 7 times x, 7s squared. 7 times minus 4x minus 28x. 7 times 1, 7. So let's subtract. This goes. 19 minus 7 should give us 12. The degree is now lower, so it means we can round up. So our answer becomes, from here, 1 over 3 into quotient x plus 7 plus remainder 12 divided by divisor s squared plus minus 4x plus 1. This should be the final answer. Okay, by the time we expand, we can write this as over 1. So 1 over 3 multiplies this one to give us x plus 7 over 3 plus, when this multiplies this, 1 over 3 of 12 is 4. That will be 4 over s squared minus 4x plus 1. And this is the proper answer. Although from the question, we have 2 plus x plus 1 over 3 and the likes. So, but this is the more proper way of writing it. So this is our final answer. Although you might be wondering that this numerator has a higher degree. This is degree 1, this is degree 0. So the thing is, in partial fraction, as far as at the denominator, we are not having any variable. There is no x here. We can leave our answer in this form. But suppose we have, let's say, 3x here. We have to still resolve into partial fraction. So for this one, the final answer is this. So let's bring this one here and clean the remaining parts. So meaning, even what we did here, this can still be written as fraction in its root for f1. So 2 times 1 is 2. So this one should be 3x plus 2, everything over 2. 3x plus 2, everything all over 2. You can write it this way since we are not having x here. So, but for this one, we must, write it in partial. We've done this. This is the first one we did. And the final answer we got the other time, that's 3 minus 2 over 3x plus 1. In this case, you might be wondering, we have x here, so we should know. Why? Because already the denominator has higher degree than numerator. Then for this, we have to be very careful. X squared minus 4x minus 1, can it be factorized? If this is factorizable, then we are not done. We still have to split further. But because this particular quadratic expression cannot be factorizable, then it means what? We'll leave it in this form. So the first thing we've done already is, if we have improper fraction or a particular fraction whereby the numerator and denominator have the same degree, we know how to go about that. In fact, for this one we are also done, but the only thing is, how can we get the value of a and b, a, b, c, a, b? How can we go about that? And that is very simple. We are going to turn it towards linear equation, or sometimes it will lead to simultaneous equation. So let's take those examples. So let 6 to 9 disappear. So by the time we solve all this question 1 to 5, you should not have any issue with partial fractions. So let's take from the first. So this is what we have after splitting. So what are we going to do? We are going to write this as a single fraction also. So what we have here, we write it here, then this one as a single fraction. So for this, the LCM is the product 2x plus 1, x plus 2. And when 2x cancel 2x plus 1, we have an x plus 2 multiplying a. That will be a into x plus 2. Plus x plus 2 cancel x plus 2, you have 2x plus 1 multiplying b. That's b into 2x plus 1. So by doing this, we've established something. They have the same denominator. If two fractions are equated and they have the same denominator, it means the numerator must also be the same thing. So it means 4 minus x must be equals to a into x plus 2 plus b into 2x plus 1. Then from here, we have many methods. We have about 2-3 methods we can use to solve. But for this lecture, I'll use only one method. Then you can use other method if you learn them outside this video. So what are you going to do? We'll expand. We want to compare coefficients. So this remains 4 minus x. Why this one is ax plus 2a. This one is what? 2bx plus b. So this remains 4 minus x. Now let's rearrange. Let's put those with x together. I have ax, I have 2bx. X is common. So if I factorize x, for this one I will have a, for this one I will have 2b. Then plus, these are constant without any x. 2a plus b. So meaning if this and this are beside each other and x is common, we have a plus 2b. And x will be outside, then here we have 2 plus b. What next? We will now compare the coefficients. Here, the constant here is 2a plus b. 2a plus b is a constant at the right hand side. And at the left hand side, the constant is 4. Equation 1. What we have beside x here is what? A plus 2b. A plus 2b. And what we have beside x is minus 1. Equation 2. Then we solve simultaneously to get the value of a and b. So we can use elimination method. So I can multiply this one by 2. So it becomes 2a plus 4b equals minus 2, equation 3. Then equation 1, we have 2a plus b equals to 4. This equation 1, we can subtract. 2a cancel. 4b minus b, that's 3b. Minus 2 minus 4 is minus 6. By the time you divide by 3, b equals to minus 2. Now that we have b, we can get a. Coming back to equation, let's use equation 2 in this time around. A plus 2b is minus 1. A plus 2, what is b? Minus 2 equals to minus 1. From here, 2 times minus 2 is minus 4. So it means a minus 4 equals to minus 1. From here, it means a equals to minus 1 plus 4. So it means a equals 3. So b is minus 2, a is 3. So note our aim is to note the value of a and b. So from there, it means our final answer equals to, what is a? 3. That's 3 over 2x plus 1. The what is b? Minus 2. Minus 2 over x plus 2. And that's all. So it means if we resolve this into partial fraction, the final answer is going to be this. So what's the first thing? Split. Second, combine as a single fraction, then compare coefficient, solve simultaneously, then get the value of a and b. If you don't really understand, rewind and rewatch, then focus on the next one. Alright, question 2. So, similar thing we did for question 1, we do it here too. We combine everything here as a single fraction. And the LCM is x plus 1, x plus 2, x plus 3. Then we move on. X plus 1 cancel x plus 1, so the remaining 2 multiply a. So we're having a into x plus 2, x plus 3. Then if x plus 2 cancel x plus 2, these 2 multiplies b. So I have b into x plus 1, x plus 3. Then if x plus 3 cancel x plus 3, this first 2 multiply c. That's c into x plus 1, x plus 2. Okay, we can still use, okay, from here, they have the same denominator, it means numerator equals numerator. We can use similar approach. We expand everything here, then at the end, we are going to have x squared with coefficients. X with coefficient and constant, then we'll compare coefficients. Or we can use another method. What's the other method here? If I'm to impute x to the minus 2 here, if x equals to minus 2, so this becomes minus 2 plus 2, everything becomes 0. Everything becomes 0. Then from there, we can focus on getting the value of b. When I put x to be minus 1, this goes away, we get the value of a. And if we put x to be minus 3, this goes away, then we get the value of c. So this one will avoid us, solving simultaneous equation. In short, pick a bracket here, x plus 2 equal to 0. So if x plus 2 is 0, it means x equals to minus 2. So you come here and impute x to minus 2. Let's do that. So if x equals minus 2, recall, they have the same denominator, so the numerator must be equal. So instead of x raised minus 2, minus 2 squared is 4. Then 7 times minus 2 minus 14 plus 8 equals to, if we put minus 2 here, minus 2 plus 2 0, everything becomes 0. Then this also, because we have plus 2 here, this also becomes 0. Then we have b into minus 2 plus 1 minus 1. Minus 2 plus 3, 1. So from here, 4 minus 14 is minus 10, plus 8 that's minus 2, into minus b. From here it means b equals 2. We will not solve simultaneous equation. They will come here. Let's now impute x to the minus 1. So if x equals to minus 1, we'll put here minus 1 squared, 1. Minus 1 times 7 minus 7, then plus 8 equals to, you put minus 1 here, we have a into minus 1 plus 2, 1. Minus 1 plus 3, that's 2. Then put minus 1 here, minus 1 plus 1, 0, everything here goes. Minus 1 plus 1, 0, everything here goes. So let's do this one. So 1 minus 7 is minus 6 plus 8, that is 2, equals to 2 times 1, 2, that's 2a. From there it means if we divide both by 2, a equals 1. Now to get c doesn't have x plus 3. So let's x to minus 3. So if x equals minus 3, we'll come here, minus 3 squared, 9. Minus 3 times 7 minus 21, then plus 8, this 8, equals to, if you put minus 3 here, this one cancel, minus 10, this one cancel, then we have c. Minus 3 plus 1, that is minus 2. Minus 3 plus 2, that is minus 1. So here, 9 minus 28 will give us, so 9 minus 21 will give us minus 12. Minus 12 plus 8 will give minus 4. So from here it means minus 4 equals to minus 2 times minus 1 is 2, 2c. From here, if we divide also by 2, we get c to be minus 2. Sorry, c to be minus 2. So we've gotten the value of a, b, c. So now come here, the final answer becomes, what is a? 1. That will be 1 over x plus 1. Then what is b? B is 2. Plus 2 over x plus 2. And what is c? Minus 2. Minus 2 over x plus 3. So if you resolve this in partial fraction, we get this. So it is easier to use this method than expanding, compare coefficient, it will lead to simultaneous equation. In this case, this will even lead to simultaneous 3 linear equation. 3 linear. So, and in our previous lesson, I think we only focus on solving simultaneous 2 linear equation. Whenever we have 3 equations, one of those methods we use is to use matrices, and we'll still come back to matrices later. So let's move to question 3. As usual, LCM. The LCM here is the one with the highest degree. S plus 3 all squared over, this one take the square away, so I'll be having a multiplying x plus 3 plus this, and this is 1 times b, and equals to have here 2x plus 3 divided by x plus 3 all squared. The other same denominator. Then this one directly we can just, so this is 2x plus 3 equals to ax, ax plus 3a plus b. This one doesn't have x, so this is a constant. So we can just compare coefficient straight. So from here, what we have beside x here is a, beside x here we have 2, so it means a equals 2. Then the constant here is 3, the constant here is 3a plus b. And 3a plus b equals to 3. What is a? A is 2. 3 into 2 plus b equals 3. 6 plus b equals 3. So b equals to 3 minus 6. B equals to minus 3. This looks more difficult than it is. So our value of a is 2. 2 over what? X plus 3. And what value of 3? Minus 3 over x plus 3 all squared. If we combine this, we get this. If we resolve this, we get this. Let's move to number 4. Same way, the LCM is the one with the highest degree, which is 2x minus 1 all cubed. So when this one takes the cube, we have square left, multiplying a. That's 2x minus 1 squared. For b, when square cancel cube, we have a single. That's what 2x minus 1 is power 1. Then when this takes away, we have only 1 multiplying c. That's c. How do you have here? 8x squared minus 2x over 2x minus 1 or cube. As usual, they have the same denominator. Then we can equate the numerator. So for this, we need to expand. Or wait, without even expanding, we can do something here. Done, let's expand. So we are going to have 8x squared minus 2x plus 0. For every quadratic equation, they have square, x, and constant. Since it has a constant, I put 0 here. Then this square of difference. So that will be a into brackets 4x squared minus 4x plus 1 plus 13 into 2x minus 1 plus c. So we still have 8x squared minus 2x plus 0 equals to, we have what? 4ax squared minus 4ax plus a plus this b, right? Looks like 13. So that's 2bx minus b plus c. So let's take all these squares together. So this square, this is the square. So we have 4a squared. We have x here, x here. So if I factorize x, we have in minus 4a and 2b. That will be minus 4a plus 2bx. And for the constant, we have a minus b plus c. A minus b plus c. So by comparing coefficients, s squared, the coefficient here is 4a. S squared, the coefficient here is 8. From there, it means a equals to 8 over 4, 2. Next, we can compare this with this. The coefficient of x here is minus 4a plus 2b. Minus 4a plus 2b. The coefficient of x here is minus 2 equals minus 2. A is already 2. Minus 4 into 2 plus 2b equals minus 2. Minus 8 plus 2b equals minus 2. From here, 2b equals to minus 2 plus 8, that's minus 6. Divided by 2, b equals to minus 3. Then lastly, the constant a minus b plus c equals to what you have here? 0. What is a? 2. Minus what is b? Minus 3. Plus c equals to 0. So you have 2 plus 3 plus c equals to 0. 5 plus c is 0. Then c equals to minus 5. Sorry, there's a mistake here. When minus 8 crosses here, minus 2 plus 8 is plus 6. So b is meant to be 3. Then this will be minus. So minus 1, then c equals to 1. So we are done. We've gotten the value of a, b, c. So our answer becomes, what is a? Okay, there's no space there. Let's just put the answer there. Let's clean the a, b, c there and replace with the answer. We clean a, and a is 2. So there, this will be 2. For b, b is 3. Then c is 1. C is 1. So we are done with this. If we resolve this, we do this. If we add this, we get this. Then the last one. Similarly, the LCM here is going to be x plus 3 multiplying s squared plus 1. So x plus 3 cancels x plus 3, we have x squared plus 1. That will be a into x squared plus 1. Then we have plus. X squared plus 1 cancels x plus 1, we have x plus 3. X plus 3 multiplying bx plus c. What do you have here? 5x squared plus 8x minus 1 divided by x plus 3 multiplied by x squared plus 1. We have the same denominator, so we can equate the numerator. 5x squared plus 8x minus 1 equals to expand. Do what? Ax squared plus a. Well, this one gives us what? Bx squared plus cx plus 3bx plus 3c. So we have 5a squared plus 8x minus 1 equals to, we have square. So that will be a plus b s squared. Then we have this, we have xx. So plus, if I write the x, we will be having 3b plus cx. Then constant, we have a and 3c. That's a plus 3c as the constant. So by comparing coefficients, it means a plus b is 5. Because s squared, a plus b is 5. Equation 1. The next, 3b plus c is 8. 3b plus c is 8. Question 2. Then lastly, a plus 3c is minus 1. A plus 3c is minus 1. Sometimes you cannot avoid not having, simultaneously 3 equations. So we have 3 equations here. So how do you go about this? Don't panic. It's very simple. So since you have 3 letters, try to eliminate one of the letters. So what can we easily eliminate? From equation 1, we can say from equation 1, a equals to 5 minus b. Equation 4, 5 minus b. So now, in equation 2, anywhere you see a, we put 5 minus b. But luckily, there is no a in equation 2. So we can still remains. Then in equation 3, anywhere you see a, we put what? 5 minus b. So we impute 4 in 3. If you impute 4 in 3, instead of writing a becomes 5 minus b plus 3c equals to minus 1. From here, it means you have minus b plus 3c equals to minus 1 minus 5, that's minus 6. Equation 5. Then our equation 2 is what? 3b plus c equals to 8. Equation 2. Then if we observe, we only have BC, there's no more what? A. So we cannot get, we can solve simultaneously. So what I will do here is, in order for me to be able to get the value of B or to the value of C, I can multiply this one by 3. I want to eliminate. 3 times minus B minus 3B. 3 times 3C, 9C. Equals to 3 times minus 16, minus 6 rather, that's minus 18. BC equation 5. So by the time we add, 3B minus 3B cancel. C plus 9C, that's 10C, equals to 8 minus 18, that is minus 10. If we divide both sides by 10, C becomes minus 1. The next is to get the value of B. So I can go back to equation 5. From equation 5, minus B plus 3C equals to minus 6. Minus B, what is C? Minus 1. Minus 1 times 3, minus 3 equals to minus 6. So if I bring this one here, minus 6 plus 3 is minus 3. Cancel the negative sign. From here, we'll get B to be 3. So B is 3, C is minus 1. We cannot get A. From equation 4, A is 5 minus B. And what is B? 3. So A equals to 2. So it means A is 2, B is 3, and C is minus 1. You've gotten ABC. Then we can come back here and say the answer here becomes, what is A? 2. 2 over, let's just put the answer directly inside there. Let's put the answer directly inside. So replace this A with 2. We replace B with 3. Then we replace C with minus 1. And that is the final answer. And this will be the end of partial fraction. What is left for you is ensure you do this yourself. Thank you very much. Thank you very much. See you in my next class. And what will be our next class? Binomial expansion. The class before this is algebraic fractions. Before that, we did expansion of square, power of 2 and 3. So this time around, we go to higher degree.